I'm Erik. I'm the product director at foreseeti. So, and as Paul mentioned, I mean, cloud services are very convenient and, I mean, more importantly, more secure than what the majority of the organizations can do by themselves. So it's a huge convenience for a lot of organizations. And migrating to the cloud is becoming increasingly popular and also much easier as time go by. But securing these operations grows beyond individuals and teams very quickly because there are a lot of moving pieces in AWS, and I mean, a lot of especially smaller companies are doing this, you know, fail fast and move quickly, but that of course comes at a price where breaches due to these customer side mistakes and misconfigurations are fairly common. But again, there is no lack of tooling or security tooling. There are a lot of great services in AWS that can help you detect all of these issues. But there is no AWS service or third-party solution tries to capture all of it at the same time. So there are great services for specific issues like Macy, for example, where you detect private personal information, for example, in S3 buckets. But how that relates to the rest of the services and all of your other instances and networking, there is no real solution for taking that big picture. And that is what we are aiming to do with our solution called securiCAD Vanguard. And securiCAD Vanguard is a SaaS service that is available on AWS Marketplace. And it's a fully automated service for attack simulations and threat modeling on AWS. So securiCAD will basically ingest all of your AWS data. So to get the full picture of your environment, and that includes not just the AWS architecture itself, but also an external entry points, for example, VPNs to your on-premise environment or anything like that, or other dependencies that are relevant to the AWS environment, and that we can get the data we can get from AWS directly or from third-party services. And then based on this data, we then do a holistic security assessment of all of this. So we take everything into account in your AWS environment and conduct attack simulations on a model of your environment. So we generate a model based on all of this data, and we make a security assessment of the holistic picture of your environment. And the tool covers all major AWS services for your networking, your IAM, the compute, Lambdas, containers, and the storage services. So we take all of that into account and see how all the moving pieces fits together, and if you are exposing yourself by misconfigurations or having vulnerabilities or by any of the, for example, the top 10 things that Paul mentioned that might go wrong with your AWS environment. And the tool will not just look at the actual the configuration of your environment, but also simulate different types of attacks. For example, credential theft and loss, any privilege escalation techniques, not just via IAM, but also via other services. So for example, the attacker might be able to start a new EC2 instance and give that EC2 instance a privileged role, which the attacker then can access, and so on. Lateral movements based on the security groups and the networking model that also Paul showed. So how can an attacker move in your environment and exploit any accessible services, containers, Lambda functions, and machines in your environment. And the tool also considers known vulnerabilities based on, for example, vulnerability scanner data, either from your third-party vulnerability scanner or from built-in tools such as AWS Inspector. So we can take all of that into account, build a model of that, and then run simulations, and we let an attacker basically run wild in your environment and see what weaknesses there is in your environment. And under the hood, securiCAD leverage a subfield of artificial intelligence called reasoning with uncertainty, and the simulations are probabilistic inference with Monte Carlo simulations. So basically, we have a lot of probabilities built into the tools. So the probability that an attacker will succeed with certain type of attacks, but a lot of it is also just the logic of AWS. So if you have a security group open or you have a permission on a specific role, the attacker will be able to use those permissions and use the traffic as you have designed it in your AWS environment. And with these Monte Carlo simulations, we also do shortest path calculations. So we can find the shortest path from the attacker's entry point, whether it's from the internet or from a VPN gateway or wherever it might be, the shortest path from that entry point to your high value assets in your environment. And based on the simulation, securiCAD will then quantify the risk of a successful attack and also generate a report on risk exposure, any weaknesses or misconfigurations found, and also critical attack paths. So these are the shortest path from the attacker to your high value assets. And these critical paths will then expose any weaknesses or misconfigurations and hotspots or vulnerabilities that the attacker is exploiting to reach one or all of your high value assets. And with that said, I'm going to jump into a short demo of this so you see how and that it actually works. So this is a small demo environment that we have running in AWS. So we have two VPCs. There is some peering between these VPCs. We have an internet-facing web server here with some sensitive data in it. There is another VPC with the Bastion host where the developers, for example, can SSH to these instances. There's also some RDS databases in private subnets here. So I'm going to jump over to Vanguard here. And as I mentioned, this is a SaaS service. It's available on Marketplace. And you can just sign up and start using it. And you can actually, we have a trial period now, so you can sign up and try it for free. And you can either try it with our demo data, or you can just use your own AWS environment as well. So as I mentioned earlier, the tool fetches data from AWS and builds a model of your environment based on that data. So the tool will need access to the environment. There's no privileged access needed. So we only need read access to very specific services and APIs. So for example, to describe all the instances, describe all the security groups, list all the IAM users, and so on. And there are templates for the policies needed in Vanguard as well. So there are a few options to do this. Either you can provide a tool with access keys here, and the tool will fetch the information for you automatically. And you can also include Amazon Inspector data here if you have done a vulnerability scan. There's another option. You can run a script locally, so so you don't have to give access keys to the tool. You can run a script locally and generate the data locally as a JSON file, and then upload that file to the tool and let it run the simulation on that. And the third option is to use our SDK available on GitHub. So this is a Python wrapper basically for the APIs. So everything I will show you today, you can do via the SDK as well, fully automatically. So you can integrate all of this into your deployment pipeline, for example, and run continuous simulations of your environment as you deploy new configurations and new assets into your AWS account. And the quantifiable aspect of the simulations makes it easy to track your risk exposure over time. For example, if the time to compromise is low, you can trigger alarms on that. And if the risk exposure goes up, you can trigger alarms on that as well, and say that you need to go back and revert this change to the AWS account because you're introducing a lot of risk into your environment based on the changes. So for the demo, I'm going to upload some data here that I have generated from our demo account. So first I have this JSON file which describes my AWS environment, or the demo environment in this case. And we can also upload additional files. So this is, if you have an additional data that describes certain parts of your environment in more detail, for example, a vulnerability scanners or information about certain accounts on certain machines, we can ingest that type of data as well to enrich the model. But it's not necessary at all to run the simulation, but it can provide some additional details to the simulation. So the things you have to do, so now it generates a model based on your data. So what you have to do is assign your high value assets in your environment. You might have a huge environment with thousands of assets, and not everything might be critical to your business, and not everything might contain sensitive data. So here you can select your high value assets, and effectively this will be the target for the attacker in the simulations. And all of this can be done automatically with the SDK as well. So I will pick a few assets here for our simulation. And the last thing we have to do is to pick the attacker profile. So what type of attacker do we want to simulate in this analysis? And this will decide how much resources and capabilities the attacker will have in our simulation. So typically a state-sponsored attacker can do, your spear phishing campaigns and develop their own exploits for software, for example. A cyber criminal might have the same type of capabilities, but not the same amount of resources. So that will lower the probability that the attacker will actually succeed in the simulation. And we have the opportunists, basically a script kiddie, which can only, exploit the obvious flaws and vulnerabilities available in the environment. So I will pick the middle one for now, and we hit simulate. And built into this model, there are certain types of attack steps and defenses that the attacker will try to exploit to reach your high value assets. So the attacker in the simulation with these Monte Carlo simulations will try anything and everything to reach your high value assets. And the more complicated attack gets, the less likely it is to succeed, of course. So now the simulation is done and we get a report. First off, we can just look at the model. So as you saw from the PowerPoint slide, we have a few EC2 instances here. We have the internet-facing web server here. We have a Bastion host over here, and we have some databases in two different VPCs. And here is the peering between those VPCs as well. And the attacker is coming from the internet in this case. So the attacker will start from the internet and try anything and everything to get into your high value assets. And there are different views of your environment. For example, your IAM setup, all the IAM users, if they belong to a role or a group, and what kind of policies there are. And we can also take a look at each virtual machine and in each VPC. And in this case, since we have vulnerability scan, we can actually get the information about what is running inside the EC2 instance, or the virtual machine in this case. But don't worry, you don't have to have this information. The tool can make assumptions about reachability and services running. So you don't have to have vulnerability scan, but it will make the simulation more detailed. So here is the EC2 instance, and these are all applications running on this EC2 instance. So OpenSSH and services like that. And all of these columns here are actually vulnerabilities that the simulation or that the vulnerability scanner has found. And we will see how that affects our risk exposure in the simulation or in the report. So we can jump back to the results here. And first of all, we get a high level look at our risk exposure. And it's fairly high in this case. And all of our high value assets are reached by the attacker. And if you remember, we picked 4 of them here. So these are all our high value assets. And for each of them, we can look closer into what happened. And we can also get a view of this, the metric that we use. So as I mentioned, with these Monte Carlo simulations, we can quantify the risk. And the metric that we use is called time to compromise, which is basically the success rate over time that the attacker will succeed with this attack. So this is the success rate, the probability of success, and this is the time in days, how long the attack takes, or how long it takes for the attacker to succeed. So we can take a look at our web server here, for example, and look at the critical path. So this is the most likely path from the attacker's entry point to your high value assets. And here we can follow all of the steps that the attacker has to take to succeed with this, and also what is allowing the attacker to succeed. So what point or what part of your AWS configuration is letting the attacker succeed with this type of attack. And here we can, for example, see there are a few security groups here that is allowing this traffic to go through. And we have an Apache Struts running on the customer web server in this case. And there happens to be an exploit here, which the attacker can use to gain code execution on this application and on the instance. So based on this CVE, we know that this type of vulnerability will give the attacker code execution. It's a critical flaw in this Apache Struts framework. And by exploiting that, the attacker gains high privilege access to the web server and basically compromises the whole web server and has full control over it. And we can also look at the sensitive data that we had in the environment. So as soon as the attacker is able to compromise this web server, he can try to do lateral movements or somehow gain more privilege than the attacker originally had. So on this EC2 instance, there is an IAM role attached, which the attacker can exfiltrate and gain and take the credentials of that role. And with this specific policy, the attacker can perform get object for this S3 bucket. So by doing all of this, the attacker can read our customer data in this case and compromise basically our whole environment. And this is the most critical path. So this is the path that is easiest for the attacker in our simulations. But since these are probabilistic models, we can look at other paths that are less likely, but still possible. So one option is, as I mentioned, if you don't have a vulnerability scanner, for example, the tool can make assumptions. So given a good enough attacker, the attacker will probably be able to, for example, develop exploits for a web server and will be able to succeed in that sense. Or find an unknown application running, or for example, spearfish a user to gain access in that way. Yeah, so for example, here we can see one of the last resorts for the attacker is to actually get a hold of that SSH key somehow. And of course, this is not very likely, but there are things you can do to actually mitigate this. For example, use MFA or don't share access or SSH keys or access keys between users and between EC2 instances. So even if they seem unlikely, they are still possible because of how you have configured your AWS environment. So let's jump back to the report. Based on all of these critical paths to all of your high value assets, we can find hotspots or points in the architecture where attacks converge. So for example, all of the traffic is going through a specific load balancer. So that might be a place where we can have CloudTrail or use Guard Duty, for example, to detect malicious traffic. We have a security group here that is also allowing all of this traffic to go through. And we can actually look at this security group directly in the AWS console. So we can have we made a mistake here, or have latest deployed changed the security group, for example, that is allowing this to happen. So we can go directly to our actual environment here and look at the security group, for example. And based on all of this, we generate a threat summary. So this is we distill basically all of the simulations and all of the thousands of attack steps and Monte Carlo simulations that we have done into this table of what is the top threat. So what is allowing the attacker to reach your high value assets. And in this case, it's one of these. We had about in our environment, but there's actually only one that is exploitable by the attacker, and it's reachable because of this security group, for example. And I also show up here because I am susceptible to privilege escalation and credential thefts in this demo environment, because on this account there's no MFA and I have access keys to a high privileged account. And with that attacker can gain access to the administrator access policy in this case. So that's a short overview of securiCAD Vanguard.